Good morning. I've got my mics on. Hopefully audio is good, just checking. Yeah, that's good. So it means that I can talk quietly and the audio quality should be really good. So I've made a little list. Hopefully I don't miss anything out, but a review of our day one. And let's begin with a bit of jargon. So in the anatomical position is always with the palms forward. So sort of even if you're standing like this, for example, when you're referring to the inner arm, it's always the anterior surface. So even when you're like that, that is the anterior surface. So there's no confusion. So here we go. The front of the body is called the anterior. So anything at the front, not just the front of the body, but the front of an organ would be called anterior. And the back is posterior. So the posterior stomach or the posterior lung. It can be the posterior cavity or the posterior body. So anterior, a posterior. And then considering we have a midline, anything towards the midline is medial. And anything towards the outside is lateral. So for example, when we've got our arms in this anatomical position, this is medial and this is lateral. And with the leg, this is the medial leg and this is the lateral leg. Medial, lateral, superior, anything above, and inferior, anything below or lower than. Often it's referred to with the heart or with an organ. So you have the superior or the inferior. Anterior, a posterior, medial, lateral, superior, inferior. Let's have distal, proximal, so distal is furthest away from, and proximal is closest to. So anterior, posterior, superior, inferior, medial, lateral, distal, proximal, superficial. Superficial is closest to the surface, and then deep is deep. We also have a plantar flexion and dorsiflexion. Plantar flexion is pointing your toes and dorsiflexion is flexing your foot. So point your toes, plantar flexion, dorsiflexion is to flex your foot. So let's do a bit of flexion as well. So from this anatomical position, flexing shortens and closes the angle, and anything that comes in is a flexion. That's a flexion, that's a flexion, a hip flexion. And an extension is anything that opens and extends and moves away and lengthens an angle. And then we have abduction, moves away from the midline. So from this anatomical position or from a central position, abduct goes away, and adduct comes in and across and close. So abduct takes away and adduct brings in close. Then we've got circumduction or circumflexion. Circumduction is one big circular rotation. We've got a pivot movement and a rotation. We've got supination, which is face up, and palms up is supination, and pronation is face down, palms down. So there's a few bits and pieces of jargon. Just going to quickly check to make sure I haven't missed out anything really obvious. Superior, medial, lateral. Yeah, no, I've got all of that. Absolutely spot on. And I'm just going to have a quick look in the muscular section just to make sure. Rotation, we don't need to know those. Inversion, adduction. Yeah, we've got it all. Perfect. So that's your jargon. I'm going to bring you a little bit closer. Okay. Oops, let's bring you up to the board just in case I need to write on the board. Okay, so I'm grabbing any pens in case I feel compelled to write on the board for you. So, do you remember that and straight away I feel compelled, how about that? So do you remember that we first of all talked about cells? And cells, basically there are trillions and trillions. Some manuals say 50 trillion, some say 3 trillion, some have 50, and then some have 70. So I think, as far as I was aware, between 70 trillion cells, of which there are hundreds of different types of cells, but there are trillions of cells that make up the body. And the body is made up of trillions and trillions of cells that, when they group together and form together, makes tissue. And there's different types of tissue. And then we'll have a group of tissue, or a selection of specialized tissue creates an organ. And then a group of organs creates a system. And of course, all the systems make up the body. Yeah. So we looked at all the different systems, and you can recap all the different systems. We don't need to go through those. I'm just going to point this away from the board so it illuminates the room but not the board. Is that a bit better? A little bit better. I'm just going to turn that light off as well. Sorry about that. Reflecting. Okay, so the cells, when we look at cells, you can have a look again at your manual, but within the cells, the most important thing for us to be looking at is the nucleus. And the nucleus is right in the center of the cell, and it contains all the information for what the cell's job is. It says you're a skin cell, you're a hair cell, you're a muscular cell, you're a nerve cell, you're an ovum, you are a genetic cell, you're creating nerve impulses, you're doing hearing, you're doing seeing. So this is the cell amongst the trillions. They all have different jobs, and all the information is held within the nucleus. There's many organelles held within the cell. The cell has a jelly-like substance within inside it that hosts and houses all these marvellous little baby organs, which are called organelles. There's lots of them in there that you'll see in the manual and you'll see in the book. But the most interesting one is this mitochondria. Mitochondria. And mitochondria is the powerhouse. It's the powerhouse that gives energy to the cell, and combined with oxygen gives life and power to each cell. So we have to feed and keep our mitochondria happy and healthy and well. So the nucleus, the mitochondria, and then the other really interesting bit for us is the membrane. We have a mucous membrane, we have fatty membranes. They're really open and very easily pass, like permeable membranes. That's what I was looking for, where particles can pass in and out through the membrane wall. So this membrane wall, this is the membrane. It can be permeable, which means it allows particles to pass through, and it can be fully permeable, or it can be semi-permeable. So when you're looking at oxygen, for example, and you're considering how oxygen passes, that's really, really easy. That's called diffusion. Really simple, easy, no problem, just like passes through. And then you've got different membrane walls with different modes of transport across the membrane wall, because you might have fatty substances that require, they dissolve into the membrane wall before they pass. There are other particles that simply can't get through, and then there are other particles that require a bonding to help them through. That's called active transport. So it's just to be aware that when we're talking about the cells, that there is that capacity for particles, for fats, carbohydrates, proteins, gases, waste to be passing through the membrane walls. The other area that we talk about permeability is in the capillaries, when we talk about the arteries, and we talk about matter passing through artery walls. That's always at capillary level, and the capillaries are permeable as well. So there'll be gases and etc. and certain matter moving through the capillary walls. That's the other time that you'll hear about this passage and this transference. Okay, so we did also talk about and look at the other way from cells, where we go into smaller cells where you've got molecules and then you've got atoms. And then you've got, atoms, and then you've got subatoms, like subatomic particles. And then when you keep going smaller and smaller and smaller, you're getting into the quantum realm of the smallest matter, which is frequency and waves, like pulse waves, standing waves, microwaves, light waves, the different waves that have frequency that carries energy and the information of energy. We don't have to review that because that's not going to be part of our syllabus, but it's just super interesting to know that everything in nature is made up of this matter. So when you're looking at energy, all in nature is made up of energy, is made up of this process of chemical constituents and compounds and molecules, subatomic particles and molecules that eventually make up the cell, that makes up tissue, that makes up the organ systems in the body. And so one of the key words that we looked at, if you remember, is the word homeostasis. Homeostasis. I think it's time to order myself some new pens. These seem to be a little bit pale. So homeostasis, this word here, homeostasis, is, if you remember, equilibrium, excuse my English spelling if it's not right, equilibrium, balance. When you have balance, you have harmony. And the body at balance and equilibrium and harmony, and this is even like the yin and yang. This is what we're talking about when we're talking about Chinese medicine and all in nature that's a process, is that when you have absolute balance, you have wellness. And that's a really cool thing to remember, is that when you've got harmony and balance and all the energetics and everything in the body is at balance, at peace, harmony, and that's also holistic. When we look at the body and we look at all of this conversation, we're looking at the holistic point of view, and that is, as we know, the mind, the body, and the spirit, or the essence, or your soul. You can have whatever word you want for that, but it's the infinite source. It's your source energy, infinite source energy, and that has a vibration as well. So when we're looking at homeostasis and equilibrium and balance and wellness, we're also considering the holistic approach. So we're looking at everything, all aspects of ourselves must be. And when we're looking at this process of the body and the movement of the body, we're looking at keeping balance and equilibrium and wellness. And that's really how we look at, like our self-care and our care for others, and the altruistic, loving, unconditional loving aspect of ourselves. Is really important, and that's why we're studying this subject, so that we can truly understand, when we're working as practitioners, why we're doing what we're doing. So let's move into the different types of tissue. So let's just quickly recap here that we have epithelial tissue. And epithelial tissue forms the lining. Oops, line, there we are, lining. Got one too many eyes in there. Oops, there. Epithelial tissue forms the lining of hollow organs and hollow tubes and tracts. Often it has this squamous epithelial tissue, the lining, often has mucus. It has a mucous membrane that will be secreting mucus that allows moisture and lubrication. For example, like the lining of the mouth and the lining of the esophagus and the whole of the digestive tract inside the ureters. So all of these inner linings of these hollow organs and tracts will have epithelial tissue. It's one cell thick and often will secrete a nice mucus or fluid to keep lubrication. There are different types of epithelial tissue as well, because you can have column shaped and cubed shaped, where they form a lining but they change shape so that they can move and expand and contract. For example, in the bladder you'll have specialized epithelial tissue that can expand and contract to help move the expansion and contraction. So you can recap that. We've also then got connective tissue. And connective tissue does that. It connects, it supports, connects and supports. The connective tissue is really abundant. It's all through so many aspects of connective tissue. So there's fascia that is connective tissue. The tendons are connective tissue. The areola and adipose is all connective tissue. And blood is connective tissue, as is bone and muscle. These are all types of connective tissue. Let me just double check here if I've missed anything out. I don't want to miss anything for you. Just one second. Specialised tissue. Oh yes, and cartilage as well. So we've got cartilage. Muscular tissue is a separate tissue, but yeah, we've got connective tissue. We've got cartilage, hyaline cartilage, yellow elastic cartilage, white fibrous cartilage, which we find in the nose and the ears, and then the white fibrous cartilage we'll find in between the vertebral discs. It's a rigid, and also in the trachea we've got cartilage as well. These are pretty solid, but they have flexibility to them as well. So they allow movement, but they're really rigid without it being solid mass like a bone. So yeah, we've got areola, adipose. So areola is like the mass of tissue that basically forms and connects everything together. And then there's yellow elastic, bone, blood and cartilage. Yeah, but blood is a liquid but a connective tissue, because it's a group of cells. When we do the cardiovascular system, there are specialized cells, red blood cells, white blood cells, platelets, and many other components to blood that forms what's called it's a tissue. So it doesn't always have to be this image of what body tissue is. Okay, so there's epithelial lining, connective tissue, many types of connective tissue, and then we do have muscular tissue. And muscular tissue are bundles of fibres, of spindles that group together, mass together to form muscles, that have a lot of mitochondria and need a lot of oxygen to fuel, to work, and to have that movement. Okay, and then we've got nervous tissue as well. Yeah, there's nervous tissue. And nervous tissue, when we do the nervous system, nervous tissue, these neurons, these bundles of neurons that convey impulses to and from the body and the brain that instruct movement and senses and functions. So there's a massive amount of nervous tissue when we look at the neurons in the body and the nerve branches. Cool. Ah, yes, okay. And then we have all the organs. I'm not going to go through and name the organs here, but if you look at the front of the manual or the front of the book, and you can refer to each system, so the organs and the systems that make up the body, there are, I think we've counted like 12 systems that are included. And don't forget the skin. The skin is a huge organ, specialised cells of connective tissue that forms the skin. So yeah, you can go through the organs. Please revise those. Revise the systems of the organs that make up the body. Okay, so moving on, we looked at the skin. And again, without reviewing absolutely everything to do with the skin, I'll just go through a short overview. Oh, I haven't got any water here. I haven't got any water, I haven't got any sprays, I haven't got any wipes. Okay. Sorry about that. Rub it a little bit harder. Okay. So there are so many marvellous pictures of the skin in manuals online. Do get online and just Google the skin and see what you can come up with. Well, look at the skin, see if you can get some animations of the skin. And see like a 3D. But if you remember, we looked at the skin. I'm going to draw a small picture here because you've got it in your books. But the top, if you remember, has 5 layers. The 5 layers of the epidermis. The 5 layers of the epidermis. The ones that I think is important for us to know is the top, the stratum corneum, which is the top layer, corneum, and the bottom layer, which is the germinatium, and this is the basal layer, and this is called the horny layer, which is the top layer. And it takes 28 days for new skin cells that have been made by skin cellular replication, mitosis, in the basal layer. And they replicate here, and then they rise up through the layers, and it takes 28 days for a skin cycle to rise up through to the top of the epidermis, to the corneum. As they're rising through, they become more translucent and clear, and then they become granular and keratinized, and then they become flattened and dead until they reach that top layer, and then they are shed in a process called desquamation. DESQUAMATION, desquamation. That's shedding of the skin. So up they rise through and we know that the epidermis doesn't have any blood, so that when it's a microscopic, it is literally like 0.5 of a millimeter, sometimes even thinner, like really microscopically thin. Because if you do a paper cut or you do something really cringy and it doesn't bleed, that's just the epidermis. So as soon as it bleeds, you're into the main true skin, which is called the dermis. So the dermis is the true skin. It has, and have a look in your manual, I'm not going to draw the whole thing up, but it has a blood supply. It has veins, blood veins, lymph. It has specialised cells, mast cells and scavenger cells that will scavenge any bacteria. And then we have all the hair shaft and the hair follicles within the true skin. It has the dermal papilla right at the bottom, feeding and nourishing hair so it continues to grow. And then attached to every hair, we've got the erector pili muscle that when it's cold, or sometimes if you get a bit spooked, the erector pili muscle contracts and has your hair stand on end. And it's very important for heat regulation. We'll just have a quick review. Shapes, I'll just put that down there to remind me. And water storage as well. Water storage. I forgot what I was saying. Yes, erector pili muscle. It has a very important role to play when it comes to temperature control, because that creates that standing on end and then the shivering. It also has what's called the sebaceous gland, and the sebaceous gland secretes sebum, an oil that is secreted on the skin, which creates a layer of skin. It's called the acid mantle, and it creates natural oils and ceramides that protect the skin from bacteria, and it keeps the acid alkaline balance of the skin, the pH balance of the skin, and keeps basically from the skin drying out or becoming having breakouts. So when you've got an imbalance with sebum or ceramide, alkalinity or acidity, often you can be prone to oily skin or breakouts. So it's interesting to look into skin and skin structure and how, I mean, we're doing structure and function here, but I love the subject of skin and how the skin is affected by sunlight and environment, heating, stress, diet, cold, so many things, products. And it's a real passion of mine. I adore the skin and I adore looking after my skin. And so it's a really interesting subject, but it loves to be hydrated. It has a massive water content, and we want to sort of help lock that in and keep the moisture within the tissues. Okay, we also got collagen and elastin fibers, specialized cells that keeps the skin plump and elastic. So we want to keep that all healthy and well and rejuvenated. Okay, so we also have sweat glands. I think that's everything. Nerves, yeah, there's nerves, because we know that because we have the sensation. So we'll go through these and make sure that, and the skin has the capacity to absorb and secrete and excrete. It excretes, it's so brilliant, the skin, I mean, really. It excretes waste. It's another aspect of excretion of ureic waste. Yeah, you can read all about that in the manual, books and additional skin information. Just Google more about the skin and look in the additional manual as well. On the bottom layer, the lower layer here, this is called the subcutaneous layer. And this subcutaneous layer has some specialized connective tissue called adipose tissue. This is subcutaneous layer, and it has adipose tissue. This is like a fat. It's a fatty tissue. It's the one that gives your body that lovely shape and contouring and protection and warmth. Let's have a little look at the functions here, and you can go into some further detail here. So we've got sensation, and that will be the nerve endings of touch, fluffy, sharp, hot, cold receptors. That's very specialized. It's incredible because you can just touch something really gently and really finely, and you can feel it, and these are all over your body, which is, I just think that's just remarkable. And like I said, you could have like the tiniest pebble in your shoe and you have to get it out. You can't go like, oh, I'll just walk with that tiny little pebble. You have to stop and get it out. Similarly, if you stand on something minute, you can feel it. So if you consider how brilliant and engineered and finely tuned we are, that we can feel that from the tippies of our toes and fingers up to our brain. So that's sensation. We've got heat regulation. I'll just put heat regulation there. And that is our vasoconstriction and vasodilation. The word vaso is blood vessels. And when you're hot, you have vasodilation, where the blood vessels dilate and open, sending a lot of blood to the surface of the skin, and therefore you become quite hot and flushed and red. And then the next process is that the pores open, allowing sweat to emerge, and the sweat on the skin cools the body down. And if when you're sweating, you're over wiping, the skin's not cooling, it's actually the cooling and evaporating of the sweat on the skin that cools us down. So not to over wipe if you're sweating, you just allow yourself to sweat. It's not a good look, but it's the body's ability to regulate temperature. And then the vaso blood vessels constrict. Vasoconstriction is where the blood vessels constrict and all the blood goes into the internal vital organs to keep the vital organs working. We actually look quite pale and drained, if you like, of blood. And then the erector pili muscle, it contracts, the hair stands on end and traps any air getting into the skin. And then we shiver, and it's the shivering that warms us up. So that's the body's, and that is homeostasis actually. That's part of homeostasis, is the body's innate capacity to regulate our body temperature. So we have absorption. And with absorption, we can absorb topical creams, oils, various applications of lovely essential oils that we want onto our skin. We have the capacity to absorb it through the skin. Protection. So it's the outer protective armour that protects our organs, our skeletal system. So we've got excretion or elimination. So we'll put excretion or elimination. And this is what I was saying. It has the ability to shed sweat that is not so much the heating. There's different kinds of sweat glands. You've got apocrine glands that are the sweat glands under your armpit and your groin, and then you've got eccrine glands that sweat all over the body, that does heat regulation. So the excretion of sweat, that's ureic waste, is eliminating any excess uric acid. This is secretion, and as we talked about, we have the sebaceous gland, or it's called the sediferous gland, that secretes sebum, which is the natural oil out of the skin as a protective layer. The vitamin D production from sunlight, and melanin production, again from sunlight. The pituitary gland is activated, that determines skin pigmentation. And this is where melanin is produced in the basal layer. Melanin production, pigment production that determines the colour of your skin, is activated in the basal layer by the pituitary gland. Melanocyte stimulating hormone sends a chemical message from the pituitary gland to the skin to activate melanin that changes pigmentation. And then we store and hold onto hydration and water within the skin. Right, that's that. Okay, that's skin. The conditions you can have a look at. Yeah. Some skin conditions are congenital, which means that you're born with them. Some are viral, fungal, bacterial. Okay, wow. Now we've got the skeletal system. This is a huge one. So I'm just going to go and get a little bit of water. Give me 1 minute. Let me just double check that my mics are still on. Let's just have a look. Oh yes, that battery's going to run out in a minute. Do you know what? I might just leave it here and I'm going to charge up my mics and I'm going to do a separate one for the skeletal system. I'm going to break it down into a couple of chunks, because what I don't want is that the microphone's cut out and I don't realise that they've cut out. And then I'm talking and you can't hear me. So I'm going to stop it there, which is kind of cool because you can just have a quick break and a breather, and then I'll do the skeletal system separately.